All right, gang, welcome to Chapter 2. Now let's talk about declaring variables. First of all, what is a variable? Now, a variable is a named memory location where you can store values. For example, you might have a location called items ordered. Excuse me. And you might store a 7 there. Or you might have a different location called name, and you might store Smith there. Well, I like to think of them like, storage units. You rent a storage unit and you store things in that storage unit. Now you need to know what you're going to put in there to know what size it's going to be. Is it something perishable? Do you need air conditioning on your storage unit? So there's these kinds of things when it comes to declaring variables and data types. We need to know what's going in there. Now, a data type defines how much memory is allocated for one of the items that we're storing, the range of values the item can hold, and what types of operations can be performed with the item. Now, C# data types include int, which is integer. An integer is a whole number, which can either be positive or negative. There's several types that are similar to integer, and each provides either more or less area in memory for storage. And some provide positive and negative signs, and some are unsigned. And those start with the letter U. But they're all whole numbers. Examples of integers include 12, 4,563, -2, and 0. Now, a double is a data type that's a decimal. They're similar to two other data types that we deal with when we're talking about decimals. We've got float and double. So we've got three different ways that we can store a fractional number. When I say fractional, it means it's decimal. So we have a double, a decimal, and a float. Okay. They all hold fractional numbers. Float takes up less memory. A decimal provides more precision. That is, it's accurate to more decimal places, but they're basically all floating point numbers. And they include, anything like 12.3, 47.0, -2.196. Okay. Other C# data types are char, C-H-A-R. That's a character, a single character. Okay. You can express it as single quotes because a character is single quotes. It could be uppercase, lowercase. Let's look at another one, a Boolean. A Boolean is a true or a false. That's all it holds. We usually use that when we're making decisions or looking at conditional statements. Check to see if something is true or false, and it holds that value of the word true or the word false in there. Okay. We've also got a variable we call a string. Okay. Now, a string is a data type that holds a series of characters. And those characters are expressed in double quotes. So, for example, you could have hello world. Hello world would start with double quotes and end with double quotes. Okay. Sometimes we can get away with it with single quotes, but let's try to stay formal with it. what do we have left? Let's jump over to type conversion. Now, we all know when we're dealing with math or algebra, a whole number, or an integer, times an integer will always result in an integer. A whole number multiplied by a fractional number or a decimal will always result in a fractional number, or will it? May not always. So let's say 2 times 1.5, the result is an integer. But we don't know it's always going to be that way. So sometimes it could be an integer, sometimes it's going to be a float, double, or decimal. So we have to plan for the worst, if you will. Okay. Now, one of the things that we have to take into consideration is that a string, we talked about that a second ago, is a string of characters. Now, characters we traditionally perceive as numbers. Excuse me, not numbers, but letters. And I could ask the user, input your age, and they enter 25. That's a string of characters. The character happens to be a 2 and a 5, but they were input as keystrokes of characters. And I need to understand that I acquired that input as a string. And if I want to manipulate that input in some way mathematically, I'll then need to convert that string into some numeric value. And we'll do that by parsing. Now, I've got some videos posted where you can watch where we talk about parsing and show the different tips and tricks to parse from a string to a double to an int, whatever it may be. And by parsing, all we're saying is, let's go look and see what's there and take the numeric equivalent of that string. So if it was input as a string 25, well, I'm going to parse that. I recognize 25, that's 25. 25, let's convert that to an integer. Now once it's an integer, I can store it in an integer variable and do something with it mathematically. I can't multiply a string. I can't. So if we have to have a good understanding of what data types exist and what we can and can't do with them. Okay? Now we can go the other direction. We can take a numeric value and convert it to a string. Now traditionally we output strings. So oftentimes we'll have to convert from some numeric to a string. So we acquire strings, we convert them to numbers. We want to display strings. Well, if it's a number, we have to convert it to a string to be able to display it. All right. Take your time. Pay attention in the exercise videos, and it'll make your projects a lot easier. Ask questions early and often, and I'll see you in the next chapter.